So here I have question number 90. Again, we have negative root 3 comma negative root 3, that is in the rectangular system. We want to convert this into the polar form, right? So again, what I would do is I would do x squared plus y squared is equal to r squared. So we know that gives us a 3 plus 3, that's 9. So we're saying that r squared is equal to 9. Well, therefore r is equal to plus minus 3. Again, consider this negative 3 when we're writing our four notations. And then we know that our tangent of theta is equal to y over x. Well, negative root 3 divided by negative root 3, that's just 1, right? So when we're doing tangent inverse of positive 1, that should give us our angles, right? So that is equal to theta. So theta is equal to pi over 4, right? Again, in the first quadrant it is positive, that's the reference angle. And then in the third quadrant it would be 5 pi. Right, 5 pi over 4, because it's all students take calculus, so take, right, that's where it's positive. So theta is equal to pi over 4 comma 5 pi over 4. So those are the angles we have, and that's the radius that we have, right? So now when we're talking about our possible answers, right, we have one that is obviously 3 comma 5 pi over 4. And again, you always want to keep that positive radius you kind of keep that positive radius towards the direction for which your actual x comma y exists, right? When I say it actually exists, I'm saying that 3 comma 5 pi over 4, well, 5 pi over 4 is in the third quadrant. That is where your x comma y does exist. That negative root 3 comma negative root 3 is positioned in quadrant 3. That's why you're going to have this positive radius, because you're saying that you're moving towards that angle, toward 5 pi over 4, and that makes sense because your x comma y is in quadrant 3, right? Other one you can write is a 3 comma negative 3 pi over 4, right? Now I'm doing is switching, I subtracted 2 pi, right, from this. If you do 5 pi over 4 minus 8 pi over 4, you get negative 3 pi over 4, right? So you should understand that would just be negative 3 pi over 4. This is going clockwise direction, this is counterclockwise. So you have that, and then we're looking at negative 3, right, comma pi over 4. Because pi over 4 is obviously in quadrant 1. However, you're saying that you're because of this negative, you will be going in the reverse direction, which will bring you to quadrant 3, and that is where our x comma y lies. And then the other one would be negative 3 comma negative 7 pi over 4. And again, I just subtracted 2 pi from pi over 4, right? So pi over 4 minus 8 pi over 4 gives us negative 7 pi over 4, right? And so that's really it. That's what we're talking about here. Those are the 4 answers to question number 90. So now I'll just go over 91. So question number 91 has the point 6 comma 9. Right, that's the x comma y, and we want to convert this into r comma theta. So we'll do the same thing here. We can do 6 squared plus 9 squared and do its square root. That gives us, so we have r squared is equal to 117, and then r is equal to plus minus the square root of 117, right? We know the tangent of theta is equal to y over x, or the opposite divided by the adjacent. That's 9 over 6, or 3 over 2. Tangent inverse of 3 over 2 will give us those possible angles. So one of them is obviously 56.31 degrees, right? And by doing this, we obviously get our reference angle here, right? Because 3 over 2 is a positive value. Well, in the third quadrant, you do tangent inverse, you should have another value in the third quadrant, right? And so we know this is a reference angle, so we're really just going to do 180 plus 56.31 to determine that second angle, right? And that gives us 236.31 degrees. So we have these two angles here, and now we know that our point is 6 comma 9, right? It's not negative 6 comma negative 9. If it was negative 6 comma negative 9, then yes, we would use that positive radius with this. However, it is 6 comma 9. That's in quadrant 1. Therefore, we will be using that positive radius with 56.31 degrees. So when we're doing our notation here, right, our notation here would be root 117 comma 56.31 degrees then it will be negative, or I can just say, so we can say root 117, right, comma, negative 303.69 degrees, same thing, just in the clockwise direction, and then we have negative root 117, comma, 236.31 degrees, and then we have negative root 117, comma, negative 123.69 degrees. Again, subtracting 360 from 236.31 gives us negative 123.69 degrees. So those are the four notations that we have here. And really, there's one interesting pattern. Whenever we're talking about a positive radius, right, and a negative radius, right, their angles differ. By 180 degrees. So when we say that they're opposite, right, if we say that, oh, we have something that lies here, right, and we want to use a notation in terms of this angle, right, so we have that negative radius attached or associated with this angle over here to refer to this point. Well, the difference between those two angles will be 180 degrees. So for instance, here we are looking at root 117, comma 56.31 degrees. This is in quadrant 1. This 236.31 degrees is in quadrant 3, right? But these two angles differ exactly by 180 degrees, right? 180 plus 56.31 is 236.31 degrees. So when we're talking about those opposite directions, right? Those angles, right? 56 degrees and 236 degrees will differ by 180 degrees. So that's question number 91. And there's the last question I have for this, so that's question number 92. So we have x comma y, right? And we want to convert this obviously into r comma theta. So here we have 5 comma 12, right? If you know your Pythagorean triples, this should be easy. We know x squared plus y squared, so 25 plus 144 should give us 169. Take the square root of that. We know that r is equal to plus or minus 13. Right, and so tangent of theta, we also know, is equal to 12 over 5, right, or the opposite divided by the adjacent. And so we plug this in our calculator and we get theta is equal to 67.38 degrees. Now this is what we're getting from the calculator, right? Obviously we know there's another one in quadrant 3. We add 180 to this to get our second angle. That is 247.38 degrees. This one also satisfies this equation over here. However, we're 5 comma 12, therefore we are really in quadrant 1. So when we write our four notations here, the first one, right, the first one would be 13, that's the radius, right, 13, obviously positive 13, comma 67.38 degrees. The other one would be 13, comma negative 292.62 degrees. Again, just subtracting 360 from 67.38 degrees, right? And then we would have negative 13, comma 247.38 degrees, right? And then the last one we would have is negative 13, comma negative 112.62 degrees. Again, this is just something I got by subtracting 360 from 247.38. So our four notations are these for question number 92. So thanks for watching.